Alright guys, your essential question for today is how do you use the law of sines to solve triangles? Your vocabulary are right triangle, oblique triangle, and law of sines. You will have a test over this material at a later date. Okay, let's go ahead and look at a problem at a triangle. And let's say I want you to calculate the length of side B. So there's my side B. Well, the issue I have is this a right triangle? The answer is no. So since this isn't a right triangle, I can't use my traditional trig ratios. I can't use sine as opposite over hypotenuse because I don't know what the hypotenuse is. The hypotenuse is always across from the right 90-degree angle. There is no 90-degree angle here. So we have to come up with a new formula to use when you're working with non-right triangles. So what I'm going to do to introduce this concept is, let's say that I give you a non-right triangle, and I'm going to call this angle A, angle B, and angle C. So I'm going to call this side C, side A, and side B. Okay, let's say this is a non-right triangle, but let's say that I drop a perpendicular from angle C straight down, so that forms a right triangle. I'm going to call this Y. I'm going to call this little bit X, and then this little bit I'm going to call C minus X, because remember, the whole thing is C. This little bit's X, so this chunk would be C minus X. Okay, let's take a look right quick, and let's look at angle B. So let's say that I'm just looking at angle B. If I wanted to find sine of angle B, that would be opposite, which would be Y, over hypotenuse, which will be A. So Y over A. Alright, then let's look at angle A. Let's say I have sine of angle A. Well, then that would be opposite, that would be Y, over hypotenuse, that would be B, so that would be equals to Y over B. If you notice, both of these equations have Y in it. So what I'm going to do is I'm going to cross multiply each one. So I'm going to get A sine of B equals to Y. And over here I'm going to do the same thing, cross multiply, get B sine of A is equal to Y. Notice that both of these things are set equal to Y, so that means I can set them equal to each other. So I've got A sine of B equals B sine of A. And then doing a little bit of fancy algebra, what I'm going to do is I'm going to divide by sine B on both sides. So that crosses out and that just leaves A. So I'm left with B sine of A over sine of B. And then I'm going to divide by sine of A on both sides. And then that crosses out. And so then that leaves me my law of sines formula. A over sine of A equals B over sine of B. In other words, when you have a side and you know its angle, you can make a ratio out of them. So side A over sine of angle A equals B side B over side of angle B. In fact, to generalize this, my law of sines is really A over sine of A equals B over sine of B equals C over sine of C. And this is the law of sines, and it works for any oblique triangle. Alright, so we're going to use that formula to help us solve some triangles. The first one is this scenario where it says solve the triangle, and I'm just going to draw me a triangle and label it ABC. And I notice that angle B is 70 degrees, angle C is 58 degrees, and then side A is 84. Alright, the first thing I notice is that I'm missing only one angle, so to find this angle I'd add these two up and subtract from 180, and that gives me 52 degrees. Now here's the thing about the law of sines. In order to use the law of sines, you have to have a side and its corresponding angle. So the 84 and the 52 are going to pair up. So in other words, I'm going to have 84 over sine of 52 degrees, because see, they correspond to each other. Now it doesn't matter which one I solve for. I could either solve for side B or side C, but the key thing here is that I need to make sure I pair up. If I choose side B, I need to pair that up with 70 degrees, and if I choose side C, I need to make sure I use 58 degrees. So what I'm going to do is I'm going to do B first. I'm going to have B over sine of 70 degrees. I'm going to cross multiply, so that gives me B sine of 52 degrees equals 84 sine of 70. And then to solve this for B, I'm going to divide by sine of 52. And so that'll leave me B is equal to 84 sine of 70 degrees over sine of 52, and that'll give me 100.2 for side B. Now for side C, I could use what I just found, but I'm just going to go back and use my 84 over sine of 52 and set that equal to C over sine of 58. Cross multiply, so I get C sine of 52 degrees equals 84 sine of 58 degrees. Divide by sine of 52 degrees, and then that'll give me 84 sine of 58 degrees divided by sine of 52 degrees. That'll give me 90.4, and that would be the length of side C. All right, let's look at another scenario. All right, again, let's draw our triangle first. So triangle A, B, C. It says side C is 8, angle C is 49 degrees, and angle B is 47 degrees. Again, we're only missing one angle, so to find my missing angle, I'm going to add these two and divide, not divide, but subtract from 180, and that would give me 84 degrees. If I use the law of sines, I need to make sure that I pair up the side with its corresponding angle. And so then I can label the rest of these. This will be side B and side A. And so if I correspond these up, A goes with 84 degrees, and B goes with 47 degrees. All right, and so if I set up my formula, I'd have 8 over sine of 49 degrees equals B over sine of 47. Cross multiply and divide by sine of 49. And so that would give me 7.8 for B. And then I can do a similar step to find A. So I get 8 sine of 84 equals A sine of 49. Divide by sine of 49. So I would get A is 10.5. And that would be my answer. Okay, looking at another one. Alright, this one is just meant for you to make sure you remember how to type in the minutes into your problem. And so for this one, I'm going to label this A, B, C. Side A is 17. Angle C is 98 degrees, 15 minutes. Angle B is 17 degrees, 55 minutes. And then you could use your calculator, add these two angles, subtract from 180. That'll give me 63.833 degrees. All right, and so when I match this up, this is side B, this is side C. When I match this up, 17 goes with the 63.833 degrees. B goes with the 70 degrees, 55 minutes. And C goes with the 98 degrees, 15 minutes. So when I set this up to solve it, I'm going to have 17 sine of 63.833 equals B over 17 degrees, 55 minutes. Cross multiply. And then divide by sine. And you'll be left with B is equal to 5.827. One thing I forgot to put right here was the sine in front of that. So let me go back and put it, sine of 17 degrees, 55 minutes. Alright, for the other one, I'd have 17 sine of 63.833 degrees equals C over sine of 98 degrees, 15 minutes. Cross multiply. You'll notice that it's pretty much the same process over and over again. So once you get the pattern down, it's pretty easy. And now divide by sine of 63.833. And that'll leave me 18.745. Perfect. All right, let's look at one more concrete example. And for this problem, I'm going to say that in my triangle A, B, C, that uh, side B is 37.9, and that side A is 21.4, and that angle A is 33 degrees. All right, now this one's different because I'm only given one angle, not two. So we're still going to treat this the same way. I'm going to make sure I pair up each side with its corresponding angle. So this 37.9 goes with angle B. And for the time being, I don't know what side C or angle C is, but I do know that they will pair up. So what I can do for this is just use the only thing I'm given, 21.4 over sine of 33 degrees. And the only other thing I'm given is B is 37.9 over sine of B. Now here's what I want you to notice. Because I'm trying to find an angle, this lets me know I'm going to do arc sine at the very end. Alright, so I'm going to cross multiply, so that's going to give me sine of B. I should have put 21.4 at the front. It doesn't matter, but I'm going to put that. So 21.4 sine of B equals 37.9 sine of 33. I'm going to divide by 21.4, and so that leaves me sine of B equals 37.9 sine of 33 over 21.4. And again, because I'm trying to find my angle, I'm going to do sine inverse of 37.9 sine of 33 over 21.4. And then your calculator should give you approximately 105 degrees. Now that I've got that angle, I can simply add these two together, subtract from 180, and that would give me 42. And now I can find side C by just simply doing 21.4 over sine of 33 equals C over sine of 42. Cross multiply, so I get 21.4 sine of 42 equals C sine of 33, and then divide by sine of 33, and so I get C is equal to 26.3. Very good. All right, last problem is a word problem. See if I can find it. Whoop, made it go away. Okay, there it is. Alright, it says a baseball fan is sitting directly behind home plate in the last row of the upper deck of the Comiskey Park in Chicago. I probably just said that entirely wrong. Sorry, I'm not really a baseball fan. But anyway, the angle of depression to home plate is 29 degrees 54 minutes, and the angle of depression to the pitcher's mound is 24 degrees 12 minutes. In Major League Baseball, the distance between the home plate and the pitcher's mound is 60.5 feet. How far is the fan from home plate? Well, in order to solve this problem, we're going to have to use law of sines. Keep in mind that you've got this guy sitting up here in the bleachers, and he is directly behind home plate, and then the pitcher's mound is right there. Now, from the home plate to pitcher's mound, that's 60.5 feet. And it says that the angle of depression to the pitcher's mound is 24 degrees 12 minutes. Well, the angle of depression is the same thing as the angle of elevation, so this is going to be also 24 degrees 12 minutes. And it also said the angle of depression to home plate is 29 degrees 54 minutes. So I want you to check this out right quick. So the angle of depression to home plate, so that's that big angle, that is 29 degrees, we'll put it up here, 29 degrees 54 minutes. The angle of depression to the pitcher's mound is only 24 degrees 12 minutes. So the question is, how can I figure out what this little tiny angle is right there? Well, I could subtract 24 degrees 12 minutes from 29 degrees 54 minutes, and that would give me 5.7 degrees. Now I have two of my three angles, so to figure out what this angle is, I simply add these two and subtract them from 180, and then that would give me my angle for that. But for this problem, I don't need to know that. It wants to know how far is the fan from home plate. Well, the fan is right here. See, yeehaw, from home plate. So this is X, what I want to find. If you notice, the X is directly across from 24 degrees 12 minutes, and the 60.5 is directly across from the 5.7. So I can use my law of sines for this problem. I'm going to set this up as x over sine of 24 degrees 12 minutes and set that equal to 60.5 over sine of 5.7 degrees. Cross multiply, so I'm going to get x sine of 5.7 degrees equals 60.5 sine of 24 degrees 12 minutes. I'm going to divide by sine of 5.7, and then that would give me my final answer that the distance is approximately 249.7 feet away. Alright, that's it for today's lesson.